All right, one last example. This is part B of dealing with the trash group ball tournament. So we still have the same means and standard deviations, which means our combined mean for male minus female is still the same as what it was before. So I'm going to go ahead and write those in because we are still on this part of the problem going to be dealing with a difference in height. So if we wanted to find on part B the probability that a male contestant is at least blank inches taller than his female partner. In class, I let them pick a number. I'm going to say, like, we'll say 12. We'll say a full foot taller. What's the probability that the male is at least a full foot taller than his female partner? So, again, we have the same mean and standard deviation, so that saves us a little bit of work. And I go straight to my normal model, my mean of 4.5. We're going 3 standard deviations-ish either way. You could go ahead and add and subtract and find those numbers if you wanted to label your normal model even further. And now I'm going to go into my z-score, but first I'm going to write out what I'm finding in probability notation. So I'm sticking with male minus female because that's what we already know the mean and standard deviation for. It'll save me some time. So if we want the male to be at least 12 inches taller than the female, then we want male height minus female height to be greater than or equal to, technically, 12. That would be what we're finding. Again, with normal model, the difference between greater than versus greater than or equal to is not enough to really make any kind of different process. So I'm just going to treat that like greater than. So that is what we're finding. So when I find my z-score, 12 would be my observed value minus my mean of 4.5 divided by my standard deviation of 4.25, which is 1.76. So we're talking almost 2 standard deviations above the mean, and we wanted greater than that. I'm going to shade greater. And then from there, I would go to my z-table, or again, we can use the calculator. Again, if I wanted to just use the z-score I just used, I could do 1.76 as my lower bound, and then positive 1E99 as my upper, since I'm doing greater than. And that would give me my answer. We could also do normal CDF and just go from 12, comma, 1E99, and then we would have to put in the mean and standard deviation, 4.5, 4.25. And that would give me a slightly more exact answer. Or you could look on your z-table for 1.76. Quick reminder, if you're looking on your z-table, remember your z-table is always giving you the less than probability. So that if you looked at your z-table, it would have given you 0.9608, and you would think logically, because you drew the picture, that can't possibly be this tiny little area that we shaded. Oh, right, that was the less than probability, and to find greater, I would do 1 minus that, which would give me the 0.0392. So either way, a lot of different ways you could find that probability once you have the z-score. Showing your work for the z-score is always a must. We always want to make sure we have all of that work shown. Drawing the detail or the normal model and shading it is always a must. All of that is part of your work. But you can actually find that probability a number of different ways. So about a 3.92, almost 4% chance that the male will be at least 12 inches taller than his female partner. And that is